So let's do exercise problem 14-6. A construction worker must apply the horizontal and vertical forces shown in the figure while pushing the loaded wheelbarrow 6.5 meters up the slope. Determine the work done. So that's the slope. It has an incline of 512 and the wheelbarrow is something like this. I'm not going to draw the whole thing. So and the forces are this way and this way. So this is 150 Newton and this is 200 Newton. Okay, and the wheelbarrow has traveled a distance of 6.5 meters. It needs to travel that much. So I'm going to show you two ways to do this. And first way is, now the distance traveled is in this direction, right? So what we can do is take these forces, 150 this way and 200 this way, and find the components in along this direction, right? Let's call this x, y. Along the x directions, the components of 200, 500, 150, how much of it is along the x direction? Take that and multiply with 6.5. Okay, so that would work something like this. So we have 150 here. Okay. Now we need to find its components along. I'm going to draw this line parallel to this slope. Okay. And then one perpendicular. Okay, so this is 150. So this is the component of 150 that we want, and this is theta. Let's call that theta. Okay, this is also theta. Right. So if this is theta, then this will be 150 cosine theta. What is cosine theta? Cosine theta from this triangle is, so we know that if we have a triangle that is 5 and 12, so we know that this is going to be 13. Okay, so cosine theta is 12 over 13, right? So this would be 150 times 12 over 13. So that comes to okay, so let's keep it as it is. We have to add it later on anyway. Okay, so and then same thing we're going to do for the vertical load. And I'm going to also draw an incline parallel to this and then perpendicular to this. Okay, so this is parallel to that, right? And then if I take that, then that is my angle theta, right? So that also will be theta. Okay. Now, so this is 200. So if that is theta, this will be 200 sine theta. So this is equal to 200 sine theta is 12 over 13. So now we need to add this and this, because these are the forces, these are the components of the forces, 150 components of these forces 150 and 200 that are acting along the incline. So we add them up. So 150 times 12 over 13 plus 200 times 5 over 13, right? 200 times, so this is sine theta, right? Yeah, that should be 5. I'm sorry. 5 over 13. So that comes to 215.38 newtons. So that is the net. That is the net force that is acting in this direction. Now we take that force, right? We take this net force Fx, right? Fx total, right? Fx total, and then we multiply it by, so work done U is Fx times S. So 215.38 times 6.5, so we get 1400. Okay, 1400 joules. Okay, and then another method is to say that, okay, right, method 2, you can follow either one. So here I'm saying work is equal to force times distance, but specifically I'm going to say force in the x direction times the x distance plus force in the y direction times y distance. Okay, or you can call that Sx and Sy also. Now we know the slope. We know the slope of the incline, which is given as 5, 12. So this is obviously 13. And this is similar to the triangle of the distances. 6.5 is the distance that is pushed, and we need to find if this is, if 6.5, if a distance of 6.5 is pushed this way, how much of that 6.5 takes you in this direction, and how much of that 6.5 takes you in this direction, right? So this is x, this is y. Let's call it Sx, Sy, so that it's not confused with that x and y, right? Distance along x and distance along y. So that's what we're going to find out. I'll call this S sub x, S sub y. Okay, so how do we find these Sx and Sy? Well, we have a relationship. We can ratio it out, right? Because it's the same incline, right? So 6.5 over 13, 6.5 over 13 is equal to Sy over 5, right? Sy over 5, and that's equal to Sx over 12. Okay, so this relationship is equal to 1 over 2, so Sy is equal to 2.5 meters, Sx is equal to 6 meters. Okay, like if you equate, so this is equal to 1/2, right? So 1/2 is equal to Sy over 5, then find Sy, then 1/2 is equal to Sx over 12, then you get, from here you get these. Okay, so we know Sy, Sx, go back and put here, we know Fx, Fy. So what do we get? 150 times 6 plus 200 times 2.5, right? 150 times 6 plus 200 times 2.5, that also comes to 1400 joules. Okay, so you can follow either way.